So first off, what elements exist in this reaction equation? Carbon, hydrogen, and oxygen. How many carbons are on your reactant side? Which side is your reactant side, by the way? Reactants. And which side is your products? Products. Okay. So, right side products, left side reactants. How many carbons on your reactant side? How many on your product side? 1. How many hydrogens on your reactant side? Product side? 2. Oxygens on your reactant side? And how many on your product side? 1, 2, 3. All right. What is the law of conservation of mass? Matter can't be created nor destroyed. So take a look at this reaction right now. I have 4 carbons on my reactant side. What happened to them because now I only have 1 on my product side? I just destroyed 3 carbons. That's not allowed. What about hydrogens? I go from 10 to 2. Or oxygens, I go from 2 to 3. Did I just create an oxygen? So we see with the law of conservation of mass that matter cannot be created nor destroyed. So we have a problem here. We have to end with the same amount of each atom that we start with. How do we do that, or how do we show that in a reaction equation? So we are going to use coefficients to balance our reaction to make sure that we have the same amount of atoms in the product side as we do in the reactants. So there is one trick right away I'll tell you to balancing. Actually, 2 tricks. 1, take inventory. Right here is your inventory of what's in the reaction. The next trick I will tell you is do what is alone last. What's alone in this reaction? What's all alone? Oxygen. Oxygen is all alone, so let's balance that one last. So let's start with carbon. I have 4 carbons on my reactant side. How many CO2s do I need to have 4 carbons on my product side? 4. So 4 CO2s. So this literally means I have CO2, 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 CO2. 4 CO2s. That gives me 4 carbons on my product side. Now, what do we do next? What? So, we do the hydrogen last because we already know we're going to do, or we do the hydrogen next because we already know we're going to do the oxygen last. So I have 10 hydrogens on my reactant side. What coefficient do I need in front of H2O? I need 5 H2Os to have 10 hydrogens. H2O, 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 H2O. Oh, I'm running out of room. H2O. 2, 4, 6, 8, 10. That gives me 10 hydrogens. Now, count up your oxygens on your product side. 5 times 1 is 1, 2, 3, 4, 5. So 5 oxygens plus 4 times 2, 8, gives you a total of 13 on your product side. Now here's where we get to a point that you're not going to like. What times 2 equals 13? Ah, maybe you guys will like it. 6.5. If I put my assumed 1 in front of C4H10, is this reaction balanced now? No? Why not? Okay, you can't have half of a molecule, but is it balanced? Technically, yeah. Everything is the same on my reactant, or I end with the same amount of atoms that I start with. Now, yes, I agree with you. I need whole numbers in my ratio. So how do I get rid of this half? You double everything. So if I double everything, 2 times 1 is 6.5 times 2 is 13. 5 times 2, 4 times 2, 8. There is my whole number ratio between all of my compounds. 2, 13, 10, 8.